In this video, we're going to talk about the laws of logarithm. So, the first thing I would like you to understand is what really is logarithm? What does it really represent, and how do we have? I want you to have an intuition of what it is. So let's take a look at this. The first thing is the way we express logarithms as follows. We say the logarithm. So if you have a number like this, log n to base b, right? This is how you pronounce it. You say logarithm of n to base b. So this is how you actually pronounce it. Then you can also write it as follows. Sometimes in textbooks, it could also be expressed as follows. So what do we mean by the logarithm of n to base b is equal to x? What do we mean by that? Okay, I would like you to have an intuition, so I'm not going to go into technicality. I'll just break it down in a very simpler form. So imagine you have 10 and I asked you how many times will you multiply 10 by itself to get 1000? So how many times will you multiply 10 by itself to get 1000? You know that the answer is 3. So you need to multiply 10 3 times to get 1000. Now, if I say how many times do you need to multiply 2 to get 32? In this case, you need to multiply 2 5 times. That is by itself 5 times in order to get 32. So what then is logarithm? Logarithm is the inverse of this kind of operation. So what logarithm is saying is, instead of you looking for 32, logarithm is saying if I have log 32, right, and I'm using to a base of 2, what will I multiply 2? That is, what should be the exponent of 2 to give you 32? So that is what logarithm is basically doing. Logarithm is interested in figuring out the exponent that gives this number. So if I say the logarithm of 1000 to base 10 is 3, what I'm saying is I need to multiply 10 by itself 3 times to get this number 1000. So basically, logarithm is more or less like the inverse of exponentiation. So the idea is when you say the logarithm of a number to a given base is 5, what you're saying is if you take that base raised to the power of the answer, you will get the number. So that is basically what logarithm is all about. So it's a very simple concept to imagine, but it could be very tricky to actually understand what really it does. So it basically helps you to figure out the exponent, the power that the base should be raised to get the given number whose log you are looking for. Okay, so now that we've gotten an intuition of what logarithm is all about, the next is let's take a look at the laws. But before we go into the laws, I would like you to have an idea of the range of numbers we'll be talking about in this class. So let's take a look. First, let's talk about the type of bases that are out there. There are several bases, but let's talk about the ones that are very popular out there. So we've got a base 10, we've got base E, and we've got base 2. These are the popular bases that you'll come across. So when you have a log of a number to base 10, you call this a common logarithm. If you have it to base E, you call this natural. Let me just look at the short, take the short form, natural log. Then if you have it in base 2, you call this binary log. This is applied a lot in maths and in other scientific areas. This is applied a lot in physics because it has a very interesting property when you talk about calculus. Then this is applied a lot in computer science. So these are the popular bases that we've got out there. But then there are other bases aside all of this. You could have base 3, you could have base 4, and any other base you can conceive. But then we are going to be dealing with positive bases. So we are not going to be dealing with negative bases in our conversation here. So now let's talk about the nature of the numbers we are going to be dealing with. Okay, we are going to be talking about numbers. So let's take a look at this example. We are going to be dealing with a number that is greater than 0, and we are going to be dealing with cases that are bounded by this. So greater than 0, that is from anything greater than 0. We are not going to be dealing with anything less than 0. So it means we are not going to be talking about negative numbers. And you may be asking, why can't we take logarithm of negative numbers? Well, it's beyond the scope of our discussion, because once you start talking about n less than 0, you tend to get into the world of complex numbers, which is beyond the scope of our discussion. So let me explain what I mean. If you have logarithm of a negative number, so let's say this is a negative number. So let me give an example here. So let's say I have log of minus, let's say 1 to base 10. So if the answer is x, what do you think x will be? So the way you think about x is, if you have, how many times will you multiply 10, right, to get minus 1? Now the issue is, if your base is a positive number, no matter what if the power is a positive number or a negative number, you can't get a negative number. So it's just like saying, how many times you multiply 10 to get a negative number? X can never be a real number. In other words, whether you are x can never be negative number, nor can it be positive number, because if x is very positive, it means the answer will be very large. Like if, for example, x is, let's say, 10, then you are talking about a very, very large number, right? If you take x to be a negative number, then you are talking about a number close to 0. So essentially, you are talking about something like this, which is something like 0.0000, maybe 0.001, something like this. So which means x can never be positive number nor negative number. So x is definitely going to be a complex number for you to get minus 1. So because x is a complex number, is beyond the scope of our discussion. So which means we are going to be dealing with numbers that are greater than 0. If n is 0, so let's say we want to take the log of 0, right, to a base b. This case too is beyond the scope of our conversation, because it's more or less like saying, when you take b raised to the power of x, right, equals 0, what do you think x would be? Like, how many times will you multiply b? So just think about it this way. So if you have a number like 10 raised to the power of x, and I say, what must x be to get 0 as the answer? Well, the only possible value that x could be to get 0 is x being minus infinity. So minus infinity is something like a very large negative number. So what that means is 10 raised to, let's say, minus 1 billion, for instance. So that will give something like 0.00000, maybe like a billion zeros. So the idea is, if you take a log of 0 to a given base, the answer is minus infinity. So which is not important in our discussion. So in summary, n in this discussion will be numbers greater than 0. So now let's go straight into the laws of logarithm. So the first law goes as follows. If you take a log of a number, so let's say number n, to base n, right? So what that means is if the base and the number are the same, what will be the answer? The answer is 1. So that's the first law. So if I have log of a number like this, 2 to base 2, right? The answer is 1. If I have log of 10 to base 10, the answer is 1. If I have log of any number 50 to base 50, the answer is 1. That is the first law. So take note of that. And the reason why it makes sense is it's just like me telling you, when you take this base, right, and ask yourself, how many times will you multiply this base by itself to get the same answer m, this number? It's just one, just one. No matter what m is, one of it will give you the number. So that's the reason why this law is correct. So the second law is this. Second law is if you have a log of n to raise to the power of p to base b, what do you get as your answer? So the law states that you can simply take this power to the back and you can express it as follows. So what this means is if I have a number like this, log 5 to base 2, and let's say the base is 2, right? I can express this as 2 log 5 to base 2. So that is what the law states. And if you think about it, I can also do the same thing here. So let's say I have log 8 to base 2. I can express it as I can express it as 2 raised to the power of 3, right? That's 2 times 2 times 2. Then to base 2. Then that will give me 3 log 2 to base 2, right? And what's log 2 to base 2? From the first law, that's 1. So this is 3 times 1. So then this gives you 3. So that's what the second law is all about. If the number has a power, you can take the power to the back of the log and multiply that power to the log of m to base b. Now let's talk about the third law. So the third law is as follows. If you have log m to base b equal to x, we can say that n is equal to b raised to the power of x. So this is basically expressing what log is all about. I told you log is all about looking for the base, for the power of the base that gives you the n, right? So this is just one of the laws. So what that implies is if I have log, let's say x to base 2 equals, let's say 5, and I ask you what's the value of x, you can easily say x is equal to 2 raised to the power of 5, and that means x is equal to 2 times 2 times 2 in 5 places. That gives you 32. So that's what the third law states. Now let's look at the fourth law. So the fourth law states that if I have log of n to base b plus log of n to base b, the fourth law states that I can simplify it as follows. I can just take log of m times n raised to base b. So what the law is stating is this. If you sum two logs with the same base, note they must have the same base, exactly the same base. You can simply take the log of that base, then multiply the numbers. So let's take a look at an example. So if I have log, let's say 2 to base, let's say 10, then I have plus log 5 to base 10. The law states that I can simply express it as log 10. Log to base 10, then the number is 2 times 5, and that will give you log of 10 to base 10. And if you can recall our first law, if you have the same base and the number is the same as the base, you can take it as 1. So this is what the fourth law states. So the next question on your mind would be, what if this plus is minus? So that's the next law we are going to look at. So let's take a look. So the fifth law states as follows. If I have log m to base b, and here we have a minus sign, that is minus another log of n to base b. Note the two have they've got the same base, right? The law states that to simplify them, you divide. You take n divided by n, then to base b. So this is it. This is what the law states. So if you have a plus, if you have plus, you multiply. If you have minus, you divide. Very easy. Minus slash plus is like a cross. So that's how you use that. That's this will help you remember. So let's take a look at an example. So let's say I have something like log of a number like let's say 2 to base 5. Then we have minus log of a number like 10 to base 5. So the question is, what is the result here? So to simplify this, we take the log of 2, then we divide by 10, right? Then to base 5. What is 2 divided by 10? So that will give us 1 over 5 to base 5. So from the laws of indices, you can express 1 over 5 as 5 raised to the power of minus 1. And this is 5. And then we simplify further by applying the second law. If you have a power on top of the number, you can take it to the back. So which gives you minus 1 times log 5 to base 5. And we know that log 5 to base 5 is 1. So that's minus 1 times 1. And then your answer becomes minus 1. Okay, so that's the fifth law. So let's talk about the sixth law. So the sixth law is as follows. If you have log m to base a and you intend to change the base, so you want to change base a to base b. So how do you go about it? So this is like a kind of change of base law. You want to change the base from A to B. So how do you go about it? So you can easily do that by saying log m to base A is equal to log m to base B, everything divided by log A to base B. So look at what I did. The first thing is to have your log to base B, right? Then you take this number to the number of the numerator, and you take this previous base to the number of the denominator. So that is how you convert from any base to another base. So let's take a look at the last law here, which is the seventh law, which goes as follows. So if I have log m to base a raised to the power of b, so this time around the base has a power. So the base has an index or an exponent. So what do you do? How do you deal with the exponent? So here you can take it to the back, but what happens here is this. It becomes 1 over b log m to base a. So see the difference. When the power is carried by m, we just take the power. This is what I mean. So let's say I have log m to base b. Log m raised to the power b, then the base is a. In this case, I'm going to write as b log m to base a. But if it is the base that has the power, you invert the base. You invert the power by the time you take it to the back. But if it is the number that has the power, you just take it that way, just like this. Just take the power to the back. But if it is the base with the power, you invert the power, then multiply it to log m to base a. So that was the seventh law. There's one more thing I need to mention, which is we can call this the eighth law. So, which is if you have log 1 to a given base, the answer is 0. So what that means is it's a bit intuitive. So if you have a number like this, b, and you say, okay, what should I raise b by to get 1? Well, if you raise b by 0, you're going to get 1. So that's why the answer is going to be 0. So what this implies in reality is if I have an example like log 1 to base 20, the answer is going to be 0. Log 1 to base, let's say I have 5. The answer is also going to be 0. So these are the laws of logarithm or logarithm. So we are going to talk about real examples. We're going to solve a lot of examples in the next video. So do watch out for the next video.